All rise. Yeah, young sister, you ain't gonna stand up over there? Yeah, that's what I thought. It's the Kevin Store, the greatest physics teacher in the state. No, nay. The country. No, nay. The universe. God has bestowed you with the great Kevin Store. Today we're going to talk about resistance, especially resistors and circuits. Anybody know about resistance in series?
Oh, yes.
Young Bucky?
When you have a resistor in series, you add them up, just a summation, and when you have them in parallel, they're basically the inverse summation.
That's actually correct. Okay. Yeah, REQ. I'm a little hungry today. There's a little place down the street called La Madeline. Ooh, so good. You see, Cowboys can even get a victory every once in a while. God felt bad for them, so he gave them a victory. Say R1, let's make that 20 ohms. 20 is my favorite number. Okay. Let's make R2 3 ohms. Like how many wins the Cowboys have this year. Okay. And let's make R3 15 ohms. All right. Anybody want to calculate the equivalent resistance?
I got it.
All back there in the academic ghetto?
The answer should be 38 ohms.
I can't hear you all the way back there. You speak up.
38 ohms, sir.
38 ohms? You're correct. Okay. All right. As the young Bucky said right there in the back in the academic ghetto, 38 ohms to get equivalent resistance equals 20 ohms for resistor 1 plus 3 ohms for resistor 2 plus 15 ohms for resistor 3. That all equals our equivalent resistance of 38 ohms. Any questions, Buckies and Buckettes? No? Okay, that's what I thought. Okay, brothers and sisters, can I go a little bit further?
Yep.
Okay, girl. You learn on your third time around. All right, now we got resistors in parallel. As the young Bucky said over there, you have to add the inverses of them, so 1 over REQ equals 1 over R1 plus 1 over R2 plus 1 over R3. We're going to set these resistors. R1 equals 10 ohms. R2 equals 17 ohms. And R3, my favorite number again, you thought I forgot. Got the 20 ohms. Can anybody figure that out? No, I didn't think so. But let me. Oh, really? Okay. What's that?
4.79.
You must have used the book calculator. Equals 4.79. So, how do you calculate this? REQ, 1 over REQ equals 1 over 10. So that's resistor 1 plus 1 over 17. That's resistor 2 plus 1 over 20. So after all that, REQ equals, as the book calculator says, 4.79 ohms. Okay. All right. Brothers and sisters, can I go a little bit further?
Mm-hmm.
Okay. This problem right here is going to get a little nasty. You know what I'm saying? It's going to grow a little hair on the chest, because this one involves resistors in parallel and series. Okay, we got 4 resistors, we got 2 in parallel. Let's give this one 25 ohms. This one 50 ohms. 7 ohms for this one, 11 ohms for this one. When we calculate REQ, we have to calculate this one using the inverse, 1 over 25 plus 1 over 50. That equals, anybody have the answer?
Just a second.
I'll do it. So can anybody give me an answer? I don't got all day. We got 50 minutes.
16.7.
16.7? So after all that REQ for resistors and parallel equals 16.7. Alright. Then we gotta add the ones that are in series. So REQ equal 16.7 plus 7 plus 11 equals, I don't want to do any better, so that's beneath me. Anybody give me an answer?
34.7.
34.7. Young Bucky over there said 34.7, and that's ohms. After all that, that's the equivalent capacitance.
In buckets, we're going to learn how to calculate the voltage in a series circuit with a current of 5 amps. First, in order to find the EMF, which is voltage, the equation for Ohm's law is voltage equals current times resistance. So you're given a current of 5 amps throughout, and you have the summation of resistance 3, resistance 2, and resistance 4. All you do is multiply the current by the summation of 2 plus 3 plus 4, which gives you 5 times. Does anyone have a calculator that can calculate this for me? You over there in the purple shirt. Yes, that's right, you. Unprepared, are we?
Sorry, don't fail me.
Calculate.
This is my 4th time taking physics.
Calculate the voltage.
45 volts.
According to my book calculations, that is correct.
Hello to all the Patriots fans out there, and generally anybody else who isn't a Cowboys fan. Today I'm going to be telling you how to find the current in a parallel circuit. And one thing you should know about parallel circuits before we start is that voltage is constant throughout the parallel circuit. So this loop is going to receive 12 volts, this loop is going to receive 12 volts, and this loop is going to receive 12 volts. So the first thing that you want to do when calculating for the current in a parallel circuit is find the equivalent resistance. And in order to find the equivalent resistance, we use this formula: 1 over equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And given in our problem, R1 is equal to 2 ohms, R2 is equal to 3 ohms, and R3 is equal to 4 ohms. When we solve for this, we get, according to the book calculator, 1.083. And once you inverse this, you're going to get a value of 0.923, which is equal to our equivalent resistance. The next thing you want to do is divide the total voltage by the equivalent resistance in order to find the amount of current that you start with going through here. So current is equal to 12 divided by 0.923, which comes out to be 13 amps. Now we'll save that value for later, and we will go through and calculate the amount of current that goes through each resistor by dividing the total voltage by the amount of ohms in that one particular resistor. So the current through 1 would be equal 12 volts divided by 2 ohms equals 6 amps. And then current through number 2 would be 12 volts divided by 3 ohms equals 4 amps. And I3 is equal to 12 volts divided by 4 ohms, which gives us 3 amps. Now, when we want to find the total current, we just add the amount of current that we got for resistor 1, resistor 2, and resistor 3 equals 6 amps plus 4 amps plus 3 amps, which gives us 13 amps, which is the value that we found over here too, so we know it's correct.
Is that a 6?
That's what a 6.
Right there next to I total.
Yeah, you can't tell. I mean, I have the perfect handwriting. I mean, I know it's a little bit sloppy, but
No, I couldn't tell. That it's completely sloppy.
you're attacking me?